I'm a retired agricultural engineer. I spent 31 years with the Agricultural Research Service. Most recently, I spent the last part of my career here in Manhattan, Kansas at the Center for Grain and Animal Health Research. My primary job was to develop technology to measure grain quality. This is a near-infrared spectroscopy instrument. I had developed a technique to measure traits of single seeds, and then over the years we adapted that to look at a number of different biological materials such as insects. And that's where we got started on the Zika work, was measuring traits of mosquitoes that might transmit diseases. Any biological material has a specific chemical composition, and we can determine that chemical composition based on the incident and reflected light. And Zika virus would change the chemical composition of that mosquito slightly. So based on its chemical composition, we can determine things like, is it carrying a Zika virus? One of the biggest benefits is it's very simple, and it's very quick. You can collect many mosquitoes from the field, scan them very quickly, and determine if you have a virus outbreak. And if you have an outbreak, then you can use some other method to try to control that outbreak, or quickly determine whether what you're using to control that is determine whether it's working or not. It's a tremendous benefit to be able to scan a mosquito or any material in a few seconds. So that means you can process thousands and thousands of samples per day. It uses no reagents, so it's very cheap on a per sample basis. So it has a lot of potential in a lot of different areas. One thing I love about my career in working for ARS is the flexibility we had to work with many different research groups, many different agencies, universities, and to pull from that expertise to solve problems like this.